Should we start? Okay. Hi, everyone. Thanks for coming to my talk. My name is Zhixuan. I'm a software engineer at Tinder. Before I start the talk, how about we have some fun? So raise your hand if you love superhero movies. Okay, all of you. So raise your hand if you don't know who she is. She's the Black Widow from the Avengers. Her name is Scarlett Johansson. We're not going to talk about. We're not going to watch superhero movies today. But I will. However, I'm going to show you something just as awesome. We're going to talk about Scarlet, a library that we created at Tinder that makes WebSocket on Android as simple as 10 lines of code. Has anyone used WebSocket before? Cool. WebSocket is a communication protocol for real-time applications. It creates a persistent connection between a client and a server. Just like a phone call, it's bi-directional. The client can talk to the server. The server can also talk to the client. Here's how you would create a WebSocket connection in JavaScript. You can listen to when the connection is open and send a message to the server. You can also listen to messages from the server and log them. This is pretty cool, right? But what's the big deal? WebSocket is not the only way our app talks to the server. Most of our apps already use REST. Why should we even care about WebSocket? To answer this question, let's try using an airline analogy. So raise your hand if you travel to Krakow by air. Was your flight on time? Yeah, mine was not. Okay, imagine that when you arrive at the airport and your flight is delayed. What do? I would do my best to keep myself up to date with the flight status. My favorite tool for checking flight status is Google. Let's do, so the Google search of my flight number shows that my flight is 42 minutes late. Essentially, I made a REST request to Google to check my flight status. Let's wait for 10 minutes and see what happens. Sorry, 10 seconds. Okay? So 10 seconds later, my phone still says 42 minutes. Because we have waited 10 seconds, the data on my phone is likely to be out of date. Let's refresh to get the latest flight status. So my flight status changed. My flight is now 1.5 hours late. Look how inconvenient this experience is. In order to stay up to date with my flight status, I have to manually refresh again and again. Wouldn't it be great if the airline can send me a message whenever my flight status changes? Like this, and this. When I registered my phone number with the airline, I established a persistent connection using the cellular network. The airline can send me flight status as it happens. Compared to the first approach of checking flight status on Google using REST request, this is just like having a WebSocket connection with the airline where flight statuses are sent to you. Essentially, the difference between REST and WebSocket is pull versus push. Let's take a look at this graph. On the left, we have REST. where you have to poll for updates, and you have to ask the server again and again, right? On the right, we have WebSocket, where you can just subscribe, and messages will be pushed to you. WebSocket is useful in many applications. For example, it's useful for chat apps. In fact, that's what we use WebSocket for in Tinder. WebSocket is also useful for real-time location sharing. It's great for online games. And it's useful for apps that shows real-time price. So WebSocket is powerful. However, it has a big problem. WebSocket is very difficult to maintain on Android. There isn't a good WebSocket library that helps you avoid boilerplate code and spaghetti code. Boilerplate code refers to a lot of code that does little jobs. It just adds complexity to your code base, and it makes development more difficult. Let me show you why you don't want boilerplate code. So it's already 2018. Over the years, the Android community developed many great libraries that makes Android development easy. Okay, HTTP is easy. With Retrofit, it only takes 10 lines of code to build a HTTP client. Persistent is also easy. With Room, it only takes 40 lines of code to set up a SQLite database. What do you guys think about WebSocket? WebSocket should also be easy, right? But it's not. It takes over 500 lines of code to set up, and because the existing this is because the existing libraries are low-level and verbose. So WebSocket is not easy to set up. But even if you are joining a project where WebSocket is already set up and the boilerplate code is already written, you still need to deal with spaghetti code. Spaghetti code refers to unstructured and difficult to maintain code. It's essentially unmaintainable. What makes WebSocket on Android prone to spaghetti code? Well, it's because state management is complicated on Android. We are dealing with a lot of asynchronous events here, and as programmers, we tend to focus on the happy path and overlook the error case. WebSocket is straightforward to use when the connection is open. But however, it gets complicated when you need to recover from connection failures. A WebSocket connection may fail for many reasons. It may fail when you're on a train passing through a tunnel. It may fail when the server is out of memory and tries to release resources. It may fail when your app is killed. Let's take a look at the happy path. So on this graph, the horizontal axis is time, and the vertical axis is the connection state. The vertical axis is the connection state that we want. And when the app is in background and the server is open, we don't want the connection to be turned on yet. So when the user opens the app, we want to connect to the server. And the user is still browsing the app, and we want the connection to be on. And when the user leaves the app, we want the connection to be closed. That's simple, right? Let's take a look at an error case. What if a connection failed? What should we do? So the user opens the app and connects to the server. The app connects to the server. But the server, for some reason, crashes, or the network is unstable. What we want, but the user is still in the app, right? We want to, what we want to do is retry, retry, and retry until the server is back on. So, as we just saw, the state management is complicated, and that makes WebSocket difficult. And when the state management is when state management is complicated, it takes a lot of effort to write modular code that it's maintainable. Okay. So that's why we created Scarlet. Scarlet is the first WebSocket library on Android that minimizes boilerplate code and spaghetti code that you need to write. It's declarative, so you can just describe what the endpoint looks like, and Scarlet will implement it for you. It reduces boilerplate code to as little as 10 lines of code. Scarlet is also modular, meaning that it consists of modular components that can be developed independently. We identified a few key components and created well-defined abstractions for them. We made them into plugins. WebSocket, which is the first plugin, is an interface. It hides the specific WebSocket implementation from Scarlet. The second plugin is MessageAdapter. It encapsulates the serialization and deserialization of messages. The third plugin, which is StreamAdapter, encapsulates the conversion between different asynchronous abstractions, such as RxJava and Kotlin coroutines. So let me show. I will explain each of them later. Let me first show you how to use them. What is the most popular WebSocket library on Android? Does anyone know? I think it's OKHTTP. And for parsing JSON messages, I prefer to use Moshi. And I like using RxJava to handle the incoming messages asynchronously. So all you need to do is put together different plugins. And we made a plugin for each of these libraries. And we made a few more. Because Scarlet is modular, no matter what library you prefer, you can use it with Scarlet. And in addition to those plugins, we have two more state management plugins that I will quickly go over. So Scarlet uses a lifecycle and a back-off strategy to keep the connection open for you. A lifecycle describes when the connection should open and should stay open. And when the connection is opened, when a lifecycle is on, Scarlet uses the back-off strategy you provide to retry, to calculate when to retry if the connection fails. These plugins allow Scarlet to take over state management from you so that you don't need to write any spaghetti code. More on this later. Just to recap, Scarlet is declarative and modular. It makes WebSocket as simple as 10 lines of code. Okay. Let's see a real-world example. Let's use Scarlet to add a real-time Bitcoin price to our app. To draw such a graph, we need data points. We call them tickers. A ticker represents the Bitcoin price at a point in time. We'll be using GDAX WebSocket API to fetch the latest price. So what does a WebSocket endpoint look like? It's actually very different from a REST API. In a REST API, you have a request and a response. But in the WebSocket connection, we send bi-directional messages. So according to the GDAX, according to the documentation for the GDAX API, after the connection is established, the client should send a subscribe message to the server. After that, the server will send tickers back to the client. So let's dive right in and and see some code examples. Scarlet is similar to Retrofit. It takes an interface and creates an implementation. To send a subscribe message to the server, you need to declare a method with the send annotation and specify the object you want to send. In this case, we want to send a subscribe message. A subscribe message looks like this. Because we're interested in the Bitcoin price, we want to send this message to the server. After we created an implementation of this interface, we use this method to send the subscribe message. Okay, we figured out how to send a WebSocket message, but we haven't figured out how to send it at the right moment. In order to listen to when the connection is opened, we need to declare another method with a receive annotation. This method returns a flowable of events. You can subscribe to it and send the message right there. After we send the subscribe message, the server will send us tickers. Okay. To observe the takers, we need to declare methods with this receive annotation. We need to declare another method with the receive annotation. This method returns a flowable of tickers. Let's subscribe to it and process the data. Because we're listening to the real-time price, it will receive a lot of data. Just to recap, we integrated the GDAX WebSocket API by declaring 3 methods in an interface. We used Scarlet to generate an implementation of this interface. And after we send a subscribe message to the server, we process the ticker one by one. We did it in about just 10 lines of code. That's very easy. So we have seen how declarative Scarlet is. Let's talk about plugins. These are the plugins that we have right now, and these are on the roadmap. Plugins are easy to write because they are meant to be customizable. And if someday you write your own plugin, please share it with us. And let me show you how to use plugins. If you're just starting from scratch, like we just did, here's the recommended configuration. First, create a Scarlet builder. Add a WebSocket plugin based on OKHTTP. Add Moshi, and then add RxJava 2. And there you go. That's all you need. If you are adding Scarlet to an existing project, here's how you configure Scarlet to be compatible with your app. Let's start with WebSocketFactory. A WebSocketFactory, the WebSocketFactory concept or abstraction allows Scarlet to support any WebSocket implementation. You can use OKHTTP, which we recommend, or mock HTTP server, which is useful for writing tests. Of course, you can even write your own WebSocket implementation. And we might support other WebSocket libraries in the future if you are interested. Next, let's talk about MessageAdapter. WebSocket supports text and binary messages. Scarlet uses message adapters to parse those messages, and including the ones we saw in the previous example, subscribe and ticker. We support Moshi, JSON, and protobuf. And if you are interested, we might add Jackson XML in the future. So next, let's talk about stream adapters. The data we receive from the server is a stream. It's a sequence of asynchronous values. Scarlet has a built-in stream type, and it uses stream adapters to convert the built-in stream to another stream abstractions, such as RxJava. We support RxJava 2, RxJava 1, and Kotlin coroutines. We might support live data and other stream types in the future. That's it about plugins. So once set up, you'll be amazed how easy it is to maintain Scarlet. Let's say we want to start receiving level 2 from GDAX. A level 2 provides insight. It's a piece of data that provides insights into trading. And guess how many lines of code we need to change to support this? We only need to change 2 lines of code. All we need to do is adding a new method to the interface. And let's see another example. Suppose we want to use a custom WebSocket implementation. This only requires 1 line of code. All we need to do is changing a plugin from OKHTTP to your own. Similarly, switching JSON library is also a one-line change, like this. So besides being declarative and modular, Scarlet is also reliable. As a library sponsored by Tinder, Scarlet is tested at scale in the Tinder app. We use Scarlet to deliver matches and messages to thousands of devices around the world. It has been in production for 8 months, and we have not seen any issues. Although state management is complicated on Android, Scarlet is not written in spaghetti code. The state management in Scarlet, it's very clean. It's testable, and it's also debuggable. So the secret here is the secret here is Scarlet is driven by a state machine with immutable state event and transitions. We actually wrote a Kotlin DSL for writing declarative state machines, which is available as a separate library. Let's take a detour into and to see a simple usage of this DSL. This is a water state machine. We all know that water has 3 states. It can be liquid, solid, and gas. And there are 4 possible transitions between them. Let's model this state machine in Kotlin. Let's use an object to represent each state. So we have solid, liquid, and gas. Let's do the same for events. We have a melted event. I believe it should be on frozen, and on vaporized, and on condensed. So these are the models around the state machine. And let's go ahead and declare a state machine using this DSL. All you need to do is use the create method. So let's specify the initial state, which is solid. And let's add state transitions one by one. When the state is solid and the melted event happens, we want to transition to liquid state. When we are in liquid state and something on froze event happens, we want to transition to solid state. Similarly, we have another transition here and our final one here. So that's it. It's simple and readable. This is what our state machine DSL look like. Not only that, it's also testable. After a state machine is created, you can assert that the initial state is solid. And we can also test the transition to a liquid state. And because the state machine is immutable. So we saw how declarative and testable a state machine can be. Here's the state machine that Scarlet uses. It's simple and elegant and customizable. You can use the concept of lifecycle to describe when Scarlet should keep the connection open. You can also use back-off strategy to configure how long the retry duration is when the connection fails. These two plugins allows the state machine to keep the connection open for you. That's it about the state machine in Scarlet. Let's move on. Since Scarlet was released in June, we received a lot of feedbacks from on GitHub. The most wanted feature is supporting more protocols. We are actually working on the V2 to address this need. Let's take a look at the plugins that Scarlet currently has. What we did in Scarlet V2 is we're taking the WebSocket abstraction and making it a plugin. By doing so, we can support more protocols. So that was a sneak peek into Scarlet V2. I actually have a working branch on this, and I'm super excited to discuss V2 with you. So yeah, that's pretty much all I have for this presentation. Just to recap, Scarlet is declarative and it demands minimal boilerplate code. It's modular, which makes it easy to start for beginners. It also makes it customizable for advanced users. And Scarlet is reliable because it's powered by a state machine with immutable states. Finally, Scarlet is evolving, and we're adding other protocols in addition to WebSocket to Scarlet. I hope Scarlet can make your life easier, and here's how you can start tomorrow. Thank you. I think we are a little bit early, and I'm happy to answer any questions.
Thanks for presentation. I have a question about life cycle.
Mm-hmm.
What about Android DOS? Do you have a solution to wake up a device?
No, we actually listen to the lifecycle changes on Android and in your app. So
Anyway, we need FCM to wake from the, or log, wake log.
Sorry. Can you say that again?
We need wake log to prevent the device from those, or use FCM messages to.
So the lifecycle concept in Scarlet is actually solving a different problem so I suppose your use case is you want to keep the connection open even when the app is in background. Am I right?
Yeah.
So we the lifecycle concept in Scarlet actually solves a different problem. It's a way to tell Scarlet what's happening in your app and whether I think whether the operating system decide to kill the app is beyond the scope of this library, and yeah, I think it solves a different problem. But I would love to discuss it with you offline.
Okay, thank.
Hi, thank you for presentation. I want to ask about caching. Do you have any caching mechanism for the lifecycle, for closing, or while you are retrying to maintain the connection?
What? Sorry. So, what is the use case? Why would you want to cache? I mean, what would you want to cache?
Is it on the user side? Does the user have to cache himself, like when you are using a chat and you want to, cache the chat messages? Does your library provide any mechanism, or we have to implement it ourselves?
So I think of Scarlet as a library similar to Retrofit. So I mean, in a REST API, so it doesn't persist the message for you, and it only handles the network part. So if you need to save the message, you will need to use another tool for that.
Okay, thank you.
Thank you for your question.
Thank you for your presentation. Your library is really great, and how can you compare, or does your library use something that already exists, some WebSocket HTTP? Does it use it as some module or library, or it's completely from the bottom to the top build your implementation?
We actually do not. Sorry, Scarlet actually does not. It's a very high level library. It does not know about the WebSocket, how to implement a WebSocket. What it does is it creates a well-defined interface for a WebSocket library, and it uses the interface to talk to existing WebSocket libraries. So for example, HTTP, right? We showed it in our previous example, and so HTTP is actually a plugin to Scarlet. So does that answer your question? So you can also use other WebSocket libraries instead of HTTP with Scarlet. Do we have more questions? Cool. Yeah, I will be around today and tomorrow. And yeah, hit me up if you have, if you are working on the WebSocket project or any persistent, or you're working on any persistent connections, because Scarlet v2 is going to support other protocols such as Socket.io, server-side event, and Stomp, and even MQTT. Yeah, so thank you.